half wave rectifier analysis. So here in half wave rectifier, it is utilizing only positive half cycles of input AC, right? So 0, pi, 2 pi, so on. On x-axis omega t, on y-axis input voltage, and this is the maximum voltage Vm, right? Now diode is conducting only in positive half cycles, so output waveform is in such a way. In negative half cycles, diode is becoming forward biased, right? Diode is becoming reverse biased. In negative half cycles, diode is becoming reverse bias, and there will be no current conduction. Now under analysis, let us talk about the first one, DC output volt current, DC output voltage, right? RMS current and voltage, RMS voltage. Okay. Now next, rectifier efficiency. Next, ripple factor, peak inverse voltage, form factor, right? Under analysis, let us talk about all this. So first, here let applied signal voltage, let it be VI, okay, and this VI is given as Vm sin omega t, where Vm we call it as maximum voltage, okay. Let I be the current in diode, okay. So now let us write the equation for I. It becomes Im sin omega t, and for 0 to pi, so here in graph you see for 0 to pi we are having positive cycle. So for positive cycle, diode is forward bias, so we are having current. So that current we wrote it as Im sin omega t for 0 less than or equal to omega t less than or equal to pi. Similarly, I value becomes 0 for pi less than or equal to omega t less than or equal to 2 pi. Now see the graph. Now pi to 2 pi we are getting negative cycle, pi to 2 pi. In negative half cycle, diode is becoming reverse biased and we are not finding any current. So only I wrote current as 0 between the limits pi to 2 pi, and we are having the current value as Im sin omega t for the values 0 to pi, right? So now here the value of this maximum current will be equal to Vm by Rf plus Rn. So what is Vm? Vm is nothing but maximum voltage, okay. Rn is nothing but load resistance, then Rf It is nothing but we call it as forward resistance connected to the junction diode, and the resistance is created when diode is in on position. Okay, just here we utilized the formula V equal to IR only. In place of R, what we wrote? Here the resistance is, one is the load resistor, other is the forward resistance of a junction diode when it is in on position. Alright. So now here nearly we are going to discuss about 1 to 7 quantities under analysis. Right. So now first let us talk about DC output current. Okay, DC output current. So here the formula for DC output current is 1 by 2 pi. Limits are 0 to 2 pi for one complete cycle. I d of omega t. This is the formula for IDC. Now this is equal to 1 by 2 pi. One is for positive cycle, limits are 0 to pi I d of omega t, plus for negative cycle the limits are pi to 2 pi I of d omega t. Okay, and now this is equal to 1 by 2 pi 0 to pi. Now in place of I, what we will substitute? Im sin omega t d of omega t plus pi to 2 pi. For negative cycle we are not having any current, so 0 into d of omega t. So that is equal to 1 by 2 pi integral 0 to pi Im sin omega t d of omega t plus 0. 0 into something is 0. Right. Now next let us differentiate this in UV method. Okay. So now here if we differentiate in UV method, we will get first one, this is integration. We are not using UV method. 1 by 2 pi, right? I am writing outside. Okay. Now integration of sin omega t will be minus cos omega t. Sorry, we are not using UV method. Integration of sin omega t is minus cos omega t, and again here we are having d of omega t, which is nothing but equivalent to omega, and integration of sin omega t is minus cos omega t by omega. So omega strikes off, and limits are from 0 to pi. So now this value becomes Im by 2 pi. Okay. So first we are substituting the upper limit, and next we will substitute the lower limit. So we will get 1 minus of minus 1, that is equal to, it becomes 2. 2 strikes off, and we get answer as Im by pi. So totally IDC value is equal to Im by pi. So 1 by pi value is 0.318 Im. If we want to write this in terms of voltage, we can write it as IDC is equal to Im means what I said here, Vm by Rf plus RL. So Vm by Rf plus RL. Here already pi is there, I wrote it as pi. Right? Now next what I am doing is, here RL is far greater than Rf, so we can neglect Rf. If we neglect Rf, we get IDC is equal to Vm by pi RL, or 1 by pi value is 0.318 Vm by RL. So in terms of voltage also we can write IDC value. Now the second one is DC output voltage. Okay, so here voltage is nothing but equivalent to current into resistor. VDC is equal to IDC into RL. But already we got IDC value as Im by pi into RL. Or if you want to write in terms of voltage, Im means what I said, Vm by Rf plus RL. Already here pi is there, I am writing this pi here into RL. If RL is far greater than Rf, we can neglect Rf. So VDC becomes Vm by pi RL into RL. RL strikes off and the answer becomes Vm by pi. This is output DC voltage. Now next, the third one is RMS current. Right? The third one is RMS current. Okay. So now here the formula for RMS current is IRMS is equal to 1 by 2 pi 0 to 2 pi I square d of omega t whole under root. What is RMS? Root mean square. So what the definition says? First we will take the square values of the mean of square values of harmonic terms, right? And then after that we will take the under root. First the square values, mean value of the all squares of harmonic terms, and then if we do under root we call it as root mean square. And the formula is 1 by 2 pi integral I square d of omega t under root. Alright. So now here let us substitute the value of I. We know I am sin omega t. So square is there, so I square m sin square omega t d of omega t under root. Alright. Now next, from pi to 2 pi we know current is 0, so I am not writing that. So now if we simplify we get the answer as Im by 2. If you want to write in terms of voltage, Vm by 2 Rf plus RL, because Im means nothing but Vm by Rf plus RL, we know that. I substituted that. Now similarly RMS voltage. So RMS voltage we will get as Vrms is equal to, in say, IRMS into RL. So IRMS means what we got? Vm by 2 of Rf plus RL into RL. If RL is far greater than RF, we can neglect RF. So Vrms becomes Vm by 2 RL into RL. RL strikes off and Vrms becomes Vm by 2. Right? This is RMS voltage. Now next, let us find out rectifier efficiency. So what the efficiency says, this particular half wave rectifier, how much it converted AC into DC, how much efficiency it is having, or how much AC is converted into DC. So the formula of rectifier efficiency is eta equal to DC, power delivered to the load, by AC input power, or output power by input power, we can say. In output we are getting DC, so DC power we will write. As input we are sending AC, so I wrote it as AC input power. So now this is written as PDC by PAC. Now let us find out the values of PDC, PAC, and then let us substitute in this equation. So first let us find the value of PDC. So what is the formula for power? I square R, that is I square DC into RL. Okay, the formula for power is I square R. That only I wrote it as I square DC into RL. Right? Already we found out the value of IDC. What is the value of IDC? Im by pi whole square into RL. So that is equal to Im square by pi square RL. So we got the value of PDC. Now we want the value of PAC. So PAC is written as PA plus PR. Now what is PA? Here PA is nothing but power dissipated at junction diode due to forward resistance present there. Right? Now the formula for PA, it is I square RMS into RF. Why I wrote RF? Because here power is dissipated due to forward resistance which is connected near the PN junction diode. Right? Already we find out the value of IRMS. So IRMS value is nothing but Im by 2 whole square RF, that is equal to Im square by 4 RF. Similarly PR. So PR is power dissipated at load resistor. Power dissipated at load resistor. So it is written as I square RMS into what I will say? I said load resistor, so I will write RL. So that is equal to I square M by 4, because Im by 2 is the value of IRMS. Square is there, so I wrote it as I square M by 4 into RL. Now let us substitute in PAC. Right? So PAC is nothing but PA plus PR. PA is Im square by 4 RF plus PR is Im square by 4 RL. So in both we are getting Im square by 4 as common. So RF plus RL. Now let us substitute these two values in efficiency formula. Efficiency formula is PDC by PAC. So what is the value of PDC? We got I square M by pi square into RL by PAC. What we got? Im square by 4 RF plus RL. Im square strikes off. So what we will get? This is equal to 4 by pi square RL by RF plus RL, and the value of this is nothing but equivalent to 0.406 RL. Here I am taking RL as common, it becomes 1 plus RF by RL. RL strikes off, so efficiency will be 0.406 1 plus RF by RL, or in percentages we write efficiency as 40.6%. So it is clearly showing that out of 100% of AC applied, only half-wave rectifier is converting only 40.6% of applied AC into DC. Half-wave rectifier is converting only 40.6% of AC into DC. Now next, ripple factor. So what is ripple factor? So first let us know about ripple factor. So what is ripple factor? So now in efficiency, what we said, here we are applying 100% AC, but in that only 40.6 of AC has converted into DC. So in output we are finding only 40.6% of DC. Then what about the other components which we find in output is nothing but AC components we will find. Right? This overlap on DC. So in output we will not only find the 40.6% of DC, but along this DC, over this DC, some AC components are also present. So that AC components present in output DC, we call it as ripples. Okay, nothing but the AC components. Ripples means nothing but AC components. So now let us find out such a ripple factor. Okay, let us find out a ripple factor. So now here a ripple factor is defined with gamma is equal to ripple voltage by DC voltage. Ripple voltage means nothing but RMS value of AC components present in output divided by DC voltage, that is VR of RMS by VDC, or we can also write this in current terms as IR of RMS by IDC. Already we finded the value of IDC. Now we have to find the value of IR RMS. Now here I am drawing nothing but this is output DC current, right? Output DC current. Okay. Now here in output we are also having some AC components, IR RMS, the current due to AC components, we call it as ripple current. So the resultant is nothing but IRMS. As usual, using Pythagoras theorem, we get I square RMS is equal to IR RMS square plus I square DC. But what we want? I square R RMS is equal to I square RMS minus I square DC. So IR RMS is equal to under root I square RMS minus I square DC, right? Now let us substitute this in ripple voltage. So ripple voltage means what? IR of RMS by IDC I said. So IR of RMS is nothing but under root I square RMS minus I square DC by IDC. Now let us take this IDC into root. What it becomes? I square RMS by I square DC minus I square DC by I square DC we can write, no? That is nothing but under root I RMS by IDC whole square minus 1. What is the value of IRMS? Im by 2. And what is the value of IDC? Im by pi whole square minus 1. If we simplify, we get ripple voltage as 1.21. So ripple means nothing but some AC components are superimposed on DC output. So that AC components we call it as ripples, and the ripple factor is 1.21. Now next. Now next let us go for regulation. Okay. Now next one is regulation. So here regulation means nothing but variation of DC output voltage with change in DC load current. The variation in DC output voltage with change in DC load current, that we call it as regulation. So let us write the formula for percentage voltage regulation. So this is nothing but V no load minus V full load by V full load into 100%. Okay. Now if we take ideal power supply, okay, if we take one second, if we take ideal power supply, then output voltage is independent of load current. It is independent of load current. Okay. So now full load voltage will become equal to the no load voltage. So we get, so full load will be equal to no load voltage. So we get zero regulation. Regulation is nothing but variation of DC output voltage when we change DC load current. Right? Now next. So if lower percentage For lower percentage regulation, then power supply will be better. If regulation is of a lower percentage, we will have a better power supply, right? So this is about regulation. Now next, peak inverse voltage. So the maximum voltage across diode in reverse direction. Peak inverse voltage means nothing but maximum voltage across diode in a reverse direction. Now lastly, form factor. So form factor, it is defined as ratio of RMS value of current to average DC current. RMS value Im by 2 and DC current IDC Im by pi. So on simplifying, we get form factor F as 1.57. Okay. So in such a way, if we are perfect with the formulas of IDC, okay, VDC, RMS current, RMS voltage, rectifier efficiency, ripple factor, form factor, this will be very useful for doing problems related to the half wave rectifier. So IDC value is Im by pi, VDC value is Vm by pi, IRMS is Im by 2, VRMS is Vm by 2, efficiency 40.6. Now ripple factor, we got it as 1.21 and form factor 1.57. So this is the analysis under half wave rectifier.